Alright, hello everyone. I'm Professor Caudill, and what's going on today? We are making progress in kinematic equations. So I thought today, obviously these are important, these set of equations. So I guess it wouldn't hurt to kind of put them in a calculator because I feel like homework questions, they're just going to ask like, okay, here you're given time, you're given x naught, find average of e. So um, I think maybe we can save time by just kind of sketching this out in the Jupyter notebook. And v squared. Okay, so you remember when I did this? I don't really like this. Don't like this either. Okay, so we have x. Okay, so we have this equation. We have plus v over 2. We have v equals v0 plus a times t. X is x0 plus v0 times t plus 1/2 times a times t squared. And lastly, equals v0 squared plus 2 times a times x minus x0. So that's our equations. Like again, if we run it, nothing happens. They're not like actually defined. It's just kind of pseudocode. We'll add what we need when we get to it. Okay, so I'm not too sure where we left off last time. Most of this looks familiar. Probably start here. Guess we can just pick up on this example. So car is merging onto freeway traffic. This is a 200-meter ramp. Initial velocity is 10. So I guess you can say this is a vector because you're going in this direction. 10 u hat. And that's meters per second. And it accelerates at 2 meters. So a of acceleration of the velocity vector is 2 meters per second squared. Okay, so you want to know how far it travels. So I'm guessing we use one of the formulas. So which one might answer this? So it's probably an X. So they're asking how much they're looking for time, right? How long? So we're solving for t. So we're solving for t. So we are given a t 0. So this, because the t is because there's two time variables. This looks like a headache, if I'm being honest. Um, Probably this one. So distance is 200. X is, we start at, we can just say that's 0. Okay, and plus V naught, V average. So they want the average over this distance. So that is um, V final minus V end. Over time. I think it's just 10. The book will correct us if not. So it should be. So this one, but the problem with this is it doesn't take account our acceleration. Okay, so I found V is V plus V divided by 2. So maybe it's 5. But again, doesn't matter because it's not using our acceleration. So let's see what the book's saying. My guess is it's this one, but like again, that looks like a headache. That's all I'm gonna say. All right, so first let's draw a sketch of it. Okay, so we know the initial velocity, but we don't know v. We know it's accelerating. Okay, so I correctly identified x0 is 0. Correctly identified x is 200. V naught is 10. I'm not gonna say I got this right because I didn't really specify. I just wrote V because I didn't specify that that's the V initial. That's V end. Should say V naught. And then V final. Um, acceleration is pretty easy to guess. And X. Okay, I wrote that twice. We have 4 knowns. Solving for T, like I said. And they're going to use that equation that it looks very scary. So they're going to use 200, 0 plus 10t plus 2t squared over 2. Which is 1 plus t squared. So we're going to get 20 divided by 10 is 20 equals t plus t squared. Okay, I guess you don't do that because you have to divide everything by 10. So okay, so they're gonna do a quadratic formula. Okay. Um, yeah, so we don't do quadratic formulas in the this day and age. So we're gonna say I want a variable t. So if t equals t is I'm going to say this equation is equation 0 is t squared plus 10 times t minus 200. Okay. And now we do a very special thing here. We're going to do solve equation. And we get 10, negative 2, 10, negative 20. Possible values 20, 10. We're doing seconds. So we're going to use 10 seconds. Okay, great. Easy enough. Whenever an equation contains an unknown squared, two solutions. Sometimes they're both meaningful. So, all right. A rocket accelerates. Q sub A is 20. And V final is 400 meters a second. Guessing V naught is 0. So solving for T. So we know V naught, we know A. Okay, so we're going to use this one. Maybe it would help if I number them. Okay, so we're going to use okay. We're going to use equation 3. So 400 equals 20t 40 over 2 is t 20 seconds. Okay. Acceleration of a starship. Spaceship has left Earth. It accelerates covers, so X is initial final velocities. Find V naught and V. So I think the convention is just don't write VF is what I'm gathering. So we know A. We know A, so which ones have A in it? This has an A. No, this does not have an A. This has an A. This has an A. This has an A. Okay. We're not gonna use this one because it's unlike. It's like we use everything we're given, so more likely. So it's probably going to be between these two. Probably the second, the equation number 4. X naught, we're just gonna say 0. V naught. Okay, so that's 4 times, so that's 4 divided by 2. It's 20 times 2 is 40. So 960 over 2. Okay, I'm getting 480 meters per second is V naught. And then if you want to find V, you take plus 20. I'm using equation 3 now. Plus 20 T. So 20 T 40. So let's see if the answer is 520. And we're way off. Okay, what happened here? They're using equation 5. I tried using equation 4. And they convert it to seconds. Okay. I guess we should have done that. Store it. Probably helps if everything's in the same units. So actually I think he did use equation 4. Okay, so let's ignore what he wrote because all we're going to change is this and this. Okay, so what 20? squared. Q times 20 divided by 2. Okay, so we're getting okay, so we're gonna do 1000 minus that. And then we're gonna divide it by 120. So should be negative 1192. Not getting that either. So what's going on here? Looks like they're converting this into kilometers or into meters. Okay, that's annoying, but is what it is. So they're saying this is a million meters. Okay. So we're just going to change this, add 3 zeros. 7117 133. Okay. And then use equation 4, 713 plus this, 93. Okay. So makes sense. I wish we could make this more intuitive. So I'm debating writing some like this is what I want. I want like a function like if some function is a b c. I want to do return I don't know, return stuff. I just do function and I plugged in the actual variables like 7100. Like, what do we have? 120. And I want to be able to do that, so let's see if we can do that. Usually we save time just by giving a sketch of what the language model does. Take all of this pseudo code and write something that makes it easy. A physics student can use by just plugging in known values. Let's specify we are using SimPy. Okay, that's a lot of code. A lot of code. Solution, display. Final position. Okay, so now we have these functions with parameters with givens. And we don't need this. Okay. So I do just want them at the bottom. So we have calculate position, calculate average velocity. Okay, so note, ensure all units are match. Convert cam meet if okay, so I wrote myself a little note. So we've got one. Do I want to add a number here? One. Okay, so added numbers, so now we can see. So what do we have? So we want to use equation. We want to use this one. Final position, x naught is 0. No, we want to use this one. No, we want to use this one. V naught. I like how they did this here. Um, calculate velocity. Velocity 2. So we have position. Okay, so what are we using? We're using this x naught. X naught is x equals x naught. So we're using equation 4. So we know A is 20, T is 120, V naught is V naught, right? X naught is 0. Okay, so what are we getting here? 120. This is 120. Below. So we need a 1000 at the end. So calculating initial velocity given x, oh, x, no, given, okay, given x naught, a, t, and x. Okay, so we're going to do this equation. X is 1000. We're going to have x is that. And we're going to solve equation, and that gives us I see what I did. It's gotta be a million, not 1000. I should read what I write. We're getting something a little bigger. Okay, there we go. Print, print, uh, the initial velocity is okay. Yeah, I want a next line here. Okay. Initial velocity is that. So I want this just to be reworded. Given all of that, write a new additional function that does this, which finds the initial velocity given. Okay, so I want to be able just to do that and say bring 6. A is, what was that, 20? Okay. So I like how they shorten this. See how mine's way, I use 2 lines, they get it done in 1 line. It's pretty sweet. All right. A lot of code, but I think when we know where we're all the, like we get familiar with it, it should save us a lot of time. Okay, so we can close this. The basis of Kinap's go to more interesting examples. Two bodies. Okay, so now we're doing two bodies. Even for the problem with two cars. So we're doing two separate problems. Okay. And the unknown we seek depends on the motion of both objects. Okay, so Cheetah waits and Cheetah waits and hiding in the bush. So we have a cheetah. Um, we have a cheetah. This is a gazelle. Um, Running past at 10 meters per second. So this is going V is 10 meters a second. Cheetah is going so we want to find T and displacement. Okay, so first we are going to consider our equations. So hmm, I'm not reading the strategy yet. I'm trying to think if I can do it on my own. Uh, we're finding T. We know the acceleration. I mean, okay, so we know V naught. This is at rest. Okay, we know X naught is 0. Do I say this is V naught? V naught is 10. Okay, X naught, we don't know that. Okay, so let's look at our equations. Trying to find T. So nothing sticking out. Maybe this. No. This is close. I'm guessing 3. Guessing 3, but I'm not really sure. so it's saying this is 0. So I guess really the gazelle is kind of like this, but it's moving and this is at rest. Okay. We pick the equation of motion that solves for displacement. Okay, so displacement. Okay, so using x equals v t, so constant velocity is average velocity. Okay, we should. I mean that makes sense. Because yeah, that just makes sense. Since it's not accelerating. So the gazelle is this cheetah is cheetah is 1/2 AT. Okay. So it's saying x is vt. We eliminated to find the final solution. So they're just taking the x out and then solving for t. So 2v, this is just basic algebra. It's t squared. We're going to divide both sides by t. It's t. Okay, okay. We use our functions. We could get partially the answer. So I don't need to print these all the time, do I? So we're going to use, what function are we going to use? We're using it number 4, so we're going to use x naught is 0, v naught, the cheetah is 4, t is unknown. Does that make sense? Ah, uh, x naught, v naught. Theta, we use the one with 1/2, so we use equation 4. Okay, so velocity. Okay, so that's a cheetah. And the gazelle is x equals this not x that. So do this for the gazelle. Square of 0. V average is 10. P. So solving these. Okay. Let's say G is that gazelle is that solving C and G. Solving C plus G is 0. Okay, we got the 5. Okay, let's see if we can just make this more intuitive. Given can it just be okay, I get what it's saying. We're out of time. Okay, so what is it saying? It's saying BT equals TV. So we're comparing these. So if we're solving for t, it's like saying v t minus, that'd be our equation, but the order matters. Body problem example. Yeah. So we can get the right answer with our calculator. We just have to move things around to express it right. So a lot of code today, but hoping it'll pay off. So thank you guys for hanging out. I'll see you next time. I might, I don't know. I'll probably wait another couple more lectures before I upload this to the GitHub. Just FYI. All right, I'll see you guys.